Good evening, everybody. Tonight we are going to discuss about very important topics of infrastructure technology, which is OpenStack cloud computing platform. So this is a part of infrastructure as a service, and what is infrastructure service we will discuss later on. And we prepared it, two of us, Shahid Murshid and Mubarak Hussain. I am a PhD candidate in the Textile University. And in the process, I have did some research on how to improve the OpenStack service cloud. So let's see first what we will cover in this topic. There are four different topics we should concentrate on. First thing is cloud computing, because infrastructure as a service, it is one service which is available to the user through the cloud computing. And then we will discuss on OpenStack, and obviously what are the improvements and changes we have done in the OpenStack technology. So first, what is cloud computing? In general convention way, what we do is when we share anything or want to use any application, it has to be installed in a hardware, and obviously we need some storage to run those applications. And definitely it is very costly for organizations if they want to use a large amount of resources. To overcome this problem, a new technology came in, which is cloud. Nowadays it is a hot topic in infrastructure technology, that through cloud we can use everything very cheaply. How it is? It is that the hardware we don't have to keep in one room or any organization. It can be shared from anywhere in the world. How? Through the internet. So through the cloud computing technology, we can provide hardware services to different users in any part of the world. So when we say services, then it comes infrastructure. So that's why we concentrate on infrastructure as a service. And as I mentioned, what are the resources we can share with the cloud? It is servers, storage systems, switches, routers, and everything. And another thing is that how it's going to be built, because there will be some cost involved, which is very important to be considered. So it will be built per use, like whenever we use it, based on how long we have used it, based on that we are getting the service. And nowadays there are many IaaS service providers available in the market, like AWS from Amazon, and from Microsoft is Azure. We have Google, then Verizon, Oracle, VMware, Red Hat, Rackspace. These are the major. Other than that, there are quite hundreds of providers, but these are the major players in the market right now. So when we say infrastructure as a service, there are different types of operating system available, and we concentrate on OpenStack. And why OpenStack? This is because it is free to everybody. It is open source, means nobody have to purchase any software when they use this operating system. And how the network is connected? It is a virtual network, and all component and hardwares are connected through access point interfaces. So when we study the OpenStack operating system, we see that there is a major drawback right now. It's not a major drawback, I should say, the setup that they have. I understand that can be improved, and that is our goal for this research. So if we study the OpenStack OS, we see that it is concentric to the controller node. I can show you the figure. If you see here, there are different components available here. We can see the controller here, and any application which is running, it is run through this controller. So if for some reason the controller goes down, the system will be down and the user will have no access to the system, which is not desirable. So our effort was to introduce a new approach to this setup, so that if for some reason the first one goes down, the system is still have to be up. So what we do, we introduced a second controller, and how this is managed, that we are going to show in some next slides. So as I was mentioning, so what is the purpose of introducing redundancy? The purpose is that, as I mentioned already, everything is going through the controller. We can see that only one controller is there. It is a second row on the left side. The controller, if it goes down, any request coming from any user, they will not be able to access the resources they are looking for. So as a result, the user will see there is no service, which is not desirable for any organization. So considering this thing, we have rearranged the network and introduced a new setup. If you see in the second row left side, before it was that only one controller was there. Now we have introduced a second controller over here. So in this case, what happens is the switch from the top row, it sends the request to the controller that we have introduced a router link node. So what it does is it shows that the controller managed by the router that we are using over here. So for some reason, if any service is going on and the system goes down, this router will detect that this controller is down. It will take over the second controller, which is at standby. And I should mention one thing, that everything is monitored in a real-time basis, and whatever is running in these controllers, it is synchronized with the second one with a synchronized software. So as a result, at the point everything going down, then it can start from the very instant, so that nothing is interrupted. So that is the main goal of this solution that we have over here. And at the bottom you can see block storage and object storage. Usually we have to use a dedicated memory system like NAS, so that is very costly to manage for many of the organizations. So in this way we can use whatever is needed, only that portion we can use, so that it is least cost possible. So in this slide we can see how the link node is working. So in this structure we can see that with the two controllers we are ensuring that the redundancy is confirmed. In a null signal is received from the first controller, the link node immediately sends the message to the standby controller, and then it immediately take over the operation, so that the system is not down. So maximum uptime is ensured through this solution. So it is not that we could bring out this solution all in one instant. We had to do some research and analysis. So what we did is we studied business models that exist in the IaaS platforms. So we have selected cloud service providers and we did some research, and we found that OpenStack is the one which is most suitable for working on this field. And in this way, what we did is we went through explanatory research method, and obviously brainstorming. We had to do the options they are providing right now, so that we can find out. So through the process we have noticed that it's a crucial point is this controller node, because this is the only one, if it goes down the system goes down. So we have concentrated on these things, and after research, brainstorming and reference checking, journal study, we have found that the best option is if we can introduce something that can ensure maximum uptime. Through that, a combination of cloud networking concept and the commercial factor associated are analyzed to bring out this realistic solution that we have just shown right now. So now the resultant discussion is quite a few things involved over here, but I am describing very few points due to the time limitations over here, but I believe it will cover everything. Like what we did is we have introduced virtual machines, 3 virtual machines over here, and we have selected 3 applications like email service, web service and cloud application for file sharing. Apart from that, anything can be done, but we have to select some to show that everything is working fine. So what we did is we have set up the OpenStack operating system with 9 different computers, and when we run We have seen that systems are running smoothly, access requests are sent properly, and purposely at some point we have turned down the first controller, and still we have seen that as soon as the first one goes down, the services are taken over by the standby one, and in that way we have found that it is working smoothly. And the main feature of this system, the design we have brought out, is the MikroTik router, which is the one monitoring both controllers and data. Both controllers are updated in real time through synchronization software, which ensures that everything is running smoothly without any interruption. So here is a screenshot of the results that we have seen when user logged into the OpenStack dashboard. User can monitor total system load, such as like how many VMs are there, how many vCPUs are running, how much memory being used by all the applications, and how many IPs have been activated, so that the whole thing can be seen in one screen, which makes easier for the administrator to control everything, and if anything goes down, it can be monitored right away. So references, I can mention so many things. For example, in the OpenStack architecture itself, per files that we have over there, it's like 1,000 pages. So many can be there, but I have mentioned 4 over here, which can give you overall a big understanding about the OpenStack and how our system is working here. So in the conclusion, I can say that the network which is developed over here, the system, it is a very effective one, and it depends on virtual migration and horizontal scaling techniques. And in this article, the OpenStack architecture that has been introduced has ensured the redundancy mechanism for the controller node to make the platform more reliable and fast, and it is more robust because no downtime is there. So it has been observed that all applications are running properly with the system that we have developed. So that concludes what we have introduced over here, and I thank you everybody for your time and listening to me. Thank you very much.